Hey, hi everybody, and welcome back to the channel Stats with Aaheli. This is Aaheli Bhattacharya, your friend, and today we are going to do a very satisfying topic, as you can see in the screen, which is Cramer's rule and basis in R3. Now, what is Cramer's rule? We are going to talk about it first, and then we are going to use the Cramer's rule in the process of how to prove a basis in R3 or any tuple. Okay, so anyway, coming to what is Kramer's rule and just hop onto it. See, before starting with the thing, like the actual topic, let me begin with something a little bit of intuition. Okay, see, if you have got three linear equations and three unknowns, suppose x, y, and z. Now you could solve this by substitution or row reduction, any method which you know. Now today I'm going to teach you Kramer's rule. Now what does this gives us? This gives us a direct formula, okay, which is like super clean. I'm going to show you how. Before that, let me show you the slide. Here, see. Let me zoom in a bit. Suppose there is a system of linear equations, these three linear equations, and you can see that how do you write it? The idea is that you can write it as Ax equals to B. Here, A is your coefficient matrix. What is your coefficient matrix? It is basically just the numbers in front of x, y, and z. Okay, and what is the x here? X is the column vector of your unknowns. What are the unknowns here? X, y, and z, right? And what is the B one? B is the column vector of your constants. What are the constants? The numbers on the right hand side. All right. Now, Kramer's rule says that if the determinant of A is not 0, then X is equals to determinant of AI by determinant of A. Okay, A1 actually. And then this is the general formula for AI. And for X here, it is A1, determinant of A1 divided by determinant of A. And same wise, it goes to Y. Then Y is equals to what? Here, you can see here y is equals to determinant of a2 by determinant of a, and z is equals to determinant of a3 by determinant of a. Now here you can see, then what is the next step which you got? A1 is what? A1 here is just the matrix A, but you replace the first column this with B, okay, for A1. And for A2, what do you do? For A2 is again a matrix A, but you replace the second column with again B. And for A3 is again the matrix A, but you replace the third column with B. Okay, that is it. You're just swapping out columns one at a time. And I will show you that with a real example. Here also in this slide, you can see which example I'm going to solve. See, this example we are going to solve, okay? Here we have got this given system of three linear equations. And here, first you have to do what? You have to find the coefficient matrix. What is the coefficient of x here? 1 for the first row. See, this is 1. How do you write it? Okay. See, here there are the steps written. You normally need to compute the determinant of A1, determinant of A2, and everything. So here the steps are given, but I'm going to share my journal with you so that you can see how I'm doing each and every step, so that it is better for you to understand. Okay, just a moment that I swap my screen. Just a minute. Okay, I hope my screen is visible. All right. Now, coming to what question I was giving to you. Okay, let me write down the question. Question was x plus 2y minus 3z is equals to 1. The first equation, then 2x minus y plus z is equals to 4, and then x plus 3y is equals to 5. Now you must be wondering that what I was talking about in the theory part, where I was just showing from the slide. Now when I show you the actual working here, then you can understand the slides better. Okay, so that then you will not feel that what am I saying like that. Okay, anyway, coming to the question. Now see, first you need to do what was your first step? First step is to find. See, well, the Kramer's rule is like Ax is equals to B, right? Now you need to find your A. A is what? A is the coefficient matrix. So let me write the coefficient matrix. A is equals to, here what is the coefficient of x? It is 1. So write 1, and then 2, 2, then 3, 3. minus 3 actually. Okay, so then coming to the next row, which is 2 minus 1 and 1, right? So 2 minus 1 and 1. Next is 1, 3 and 0, because there is no value of z, right? So just write 1, 3 and 0. So this is your coefficient matrix. You have already done it. Now, for this matrix, what do you need to do? You need to find the determinant of it, because that is needed. Because what I said, how to find the unknowns, you need to just give the value of determinant of A1, then divide by determinant of A. So, I will find the determinant of A just in a moment. First, let me write what are the things we have got from the question. Okay, so the next is, what is X? X is here our constants, our the unknowns, sorry. Okay, so what are the unknowns here? It is x, y and z, right? So let me write it, x, y and z. And what is our b here? B is the our constants, the right hand side part. Okay, so let me write b is equals to 1, 4 and 5. So I hope the screen is visible. When before class we were studying about vectors question only. So now I'm going to show you the vectors question, but in a different idea, different technique. Okay. For that we need the Cramer's rule. Coming to this question, see what is the next step now? Next step is that you need to find the determinant of A. Okay. So let us find that first. Determinant of A. What was the determinant? 1, 2, 1, 2 minus 1, 3, and minus 3, 1, and 0. And how do you find the determinant? Basically, you need to take this number, the first number, 1, and then multiply the cofactors, then take the cofactors. Okay, so how do you do that? Basically, first multiply like this and then minus this. Okay, now everybody knows how to calculate determinants, so I'm not showing that in this class, because that is very basic topics which we have already learned in class 10, 11, 12, right? So I'm not showing that. Anyway, just doing the calculation. If you have any doubt in determinant, then you can directly text me, then I can show you personally. Anyway, coming to the determinant solution, see minus 1 and 0 is 0, so basically minus 3, and then minus 2. Minus 2, it is like 0 minus 1, so minus 1, and then minus 3 into 6 plus 1. 6 plus 1. All right, now let us do the calculation. Minus 3 plus 2, minus 3 into 7, which is minus 21. So this is coming to be minus 22. Now, this value is important to us because we need this value for the unknowns, right? Now, for the determinant, now we need to find the matrix of A1. Now, how do I get the A1 matrix? It is just, I said that it is a matrix A only, but we need to replace the first column with B. Now, what is our B here? See, our B is 1, 4. I'm sorry, this is the highlighter. B is 1, 4, and 5. So, here in the first column, you need to write 1, 4, and 5. Okay, for the A1 matrix. And for A2 matrix, you need to replace that with the column number 2. And for A3 matrix, you need to replace the column number 3. Okay, so this is very simple, and it will be very easy for you if you practice a lot. Then this Cramer's rule will be one of the most efficient way that you find the unknowns of system of linear equations. All right. Okay, so let me find determinant of A1. Now for determinant of A1, what do you basically write? 1, 4 and 5, then 2, then this column and the second column and third column will be same only. So 2 minus 1 and 3, and then minus 3, 1 and 0. And then just find the determinant. It is like 1 into minus 1 into 0 is 0, and minus 3. So then comes minus 2 into 0 minus 5, then minus 3 into 12 plus 5. 12 plus 5 is equals to minus 3 plus 10, minus 3 into 17. Minus 3 into 17 is basically minus 51. So minus 51. So this is coming to be minus 44. Okay. So now here, how do you find the x here? X is basically determinant of A1. X is basically determinant of A1 divided by determinant of A, which is, what is the determinant of A1? It is minus 44. Minus 44 by determinant of A is minus 22. Minus 22. So basically x is equals to 2 here. So we have got our first constant. Now, what I prefer is that I prefer to first calculate all the determinants of a1, a2, and a3, and then at last I try to find the solution for the unknown constants. Okay, so unknown variables. So basically, now I have shown you this part. For the first question, I am showing you side by side, like what are the constants value. Anyway, coming to determinant of a2. For determinant of A2, what did I just say, that A2 is just the matrix of A only, but here you need to replace the second column with the B. Now, if you replace the second column with B, then it happens what? 1, 2, 1, and the second column will be 1, 4, and 5. That was the B, right? 1, 4, and 5. So 1, 4, and 5. Then the third column will be same, minus 3, 1, 0. Now you need to find the determinant of it. Like, how will you find it? 1 into 4 into 0 is 0, and minus 1 into 5, which is basically minus 5. And then minus 1 into 2 into 0 is 0, in minus 1, right? So minus 1, and then minus 3 into 2 into 5, 10 minus 4, right? So 10 minus 4. So now if you calculate it, minus 5 plus 1 minus 18. 6 into 3, 18, right? So what do we get here? Minus 22. Now from here we can get the y value. What is the y value? It will be determinant of a2 by determinant of a, which is basically, what is the determinant of a2? It is minus 22. And what was the determinant of a? It was again minus 22. See, it was again minus 22 only. So let me write it, minus 22, which is equals to 1. So here we have got our second unknown variable, which is 1. Okay. Now coming to the third one, determinant of a3. Now here again I'm telling you the same thing, that determinant, like a3 is just the matrix A, but you have to replace the third column with the B. Okay. So here what will the determinant look like? Matrix will look like 1, 2, 1. 2 minus 1 3, and the last column will be the B column, right? So it will be 1 4 and 5. Now here you need to find the determinant. So how will you find it? 1 into 1 minus 1 into 5, which is basically minus 5 minus 12. Then minus 2 into 10 minus 4, and then plus 1 into 6 minus 6 plus 1, 6 plus 1. Okay. So what is the further calculation? It will be like minus 17 minus 2 into 6, which is minus 12, and then plus 7. This is again coming to be minus 22. Now if this is minus 22, then we will get our unknown variable z by determinant of a3 by determinant of a, which is equals to minus 22 by minus 22, which is again 1. So from here, we have, in this question, we have got our solution. We have got the values of unknown constants. Okay. So what is the unknown constant? So let me write as a final conclusion, that x is equals to 2, y is equals to 1, and z is equals to 1 again. So this is our answer. Now this question is basically the first and like first question on Cramer's rule. So in the next questions, I will use this Cramer's rule only to find to prove that it is a that it, the S will be a basis of R3 or any tuple. Okay. So now coming to the actual questions, which what we want to learn. Okay. Now coming to the questions. Now, do you remember what is a basis? Like, what is a basis? A set S is a basis of a vector space V. Like, in our case, we will take R3. Okay. If it satisfies only two conditions, what is the first condition? First condition is the linear independence condition, that the vectors in S do not repeat each other. No vector in the set can be written as a combination of others, right? And here the scalars will be equals to 0, right? We are familiar with that kind of solutions, that we will solve all the linear equations, and we will get that the C1 is equals to C2 is equals to C3, which basically means that the scalars are equal to 0. Now coming to the second question, second condition is that S spans V. Now what does this mean? That S spans V or S generates V, whatever you understand. Now this means that every single vector in R3 can be written as a linear combination of the vectors in S. Now basically, for our strategy of writing the questions, It's like for the condition 1, we will form a matrix with our vectors. We will check if the determinants is non-zero. If non-zero determinant, it is meaning that it will be equals to linearly independent. All right. So this is very important for us to know that if our determinant is equals to zero, then it will be linearly dependent. If it is not equals to zero, then it will be linearly independent. So we will use that fact for this kind of question. So it will be very easy for us to solve, right? Because determinants are easy to solve. And for condition number 2, we will take a completely general vector, which is ABC in R cube, R3, and try to express it as a combination of our vectors. With this will give us a system of equations, and we will solve it using this Cramer's rule, which we have just learned. Okay. Now, if a solution exists for any ABC, then we can say that S spans all of R3. Okay, so we will do three questions today, and let us start with the first question. And I swear that these questions are very interesting when you try to solve on your own, and you see that these questions are like very important also in your exam. And even this question is very easy to solve when you use these two conditions. That is, first is determinant is not equals to zero, then it will be linearly independent, and the second condition is the Cramer's rule. Okay, please use that, then it will be very easy for you. And if you want to use the old traditional method, that is solving the linear equations, then you can watch my previous video, and there also I have solved questions on basis, but there I have used a different technique, which is that one. Okay. Okay, now coming to the first question. Question number 1 is, show that S is equals to 211, 121, and 112. Just a moment. 112 is a basis of R3. So for the first part, what do you need to write? First, you need to mention that for it to be a basis, what are the conditions it needs to satisfy, right? So that the teacher can understand that you actually know what is the meaning of basis, and then you are trying to prove that it is a basis or it is not a basis, right? So let me start with that. For this set of vectors, for this set of vectors to be a basis of R3, it must satisfy. So, what are the two conditions I just said? First is S should be linearly independent, right? S is linearly independent. And the second condition is that S generates V. S generates V. Now, for linearly independent, I said that we will form the matrix, and we will see that if it is coming to be non-zero, then we can say that it is linearly independent, right? So, let us form the matrix. Let us use a different color. Okay. So, let us say that A is equals to 2 1 1. This is the first vector. Then 1 2 1, second vector. Then 1 1 2, third vector. Now we will see the determinant of this. The determinant, how will we solve it? 2 into 4 minus 1 minus 1 into 2 minus 1 plus 1 into 1 minus 2. Okay, so what is the further solution? 2 into 3 minus 1 into 1 plus 1 into minus 1. So basically 6 minus 1 minus 1, which is 4. And 4 is not equals to 0. So we can say that hence, so S is linearly independent. Now, to prove this to be a basis of vector R3, vector space R3, then how do we proceed? We will first let xi to be ABC, which belongs to R3, okay? And for any vector where ABC belongs to R, okay? So let me write that. This is the standard notations and the standard lines that you need to write for your exam paper, okay? So coming to that, let xi is equals to ABC, which belongs to R3, be any vector, be any vector where A, B, and C belongs to R, belongs to R only. Okay. Now for this, then we can say what? Then we can say that now we can say, I'm sorry. Now we can write that A, B, C can be written as R1 into what is the first vector? First vector is 2, 1, 1 plus R2, which is 1, 2, 1 plus R3, which is 1, 1, 2. Now this can be written as a form of three linear equations, right? Now let me write it directly and you must not skip any step, okay? See, here I can see it directly. What are the three equations? First equation is 2 into R1 plus 1 into R2 plus 1 into R3. So basically it is what? 2R1 plus R2 plus R3 will be equals to what? Using the property of equal vector, it will be A. Next equation will be what? 1 into R1, 2 into R2, 1 into R1 plus 2 into R2 plus 1 into R3. So it will be what? R1 plus 2R2 plus R3 is equals to B. Now next equation, the third equation will be 1 into R1 plus 1 into R2 plus 2 into R3. So let me write it. R1 plus R2 plus 2R3 will be equals to C. Now we have got three linear equations, and just now we have studied how to use Cramer's rule for a system of linear equation, and we can get the unknown variables. Now here you can understand what is our unknown variables. It is this R1, R2, and R3. These are our unknown variables. And what are the constants here? This is the right hand side, which is A, B, and C. And what are the coefficients of R1, R2, R3? That will be our coefficient matrix. That will be we will use that for our coefficient matrix, right? So let us see that how will we use that. Okay, so coming to first the coefficient matrix. First let me write it using Cramer's rule. Please write, mention that which rule you are using during your exam. Okay, using Cramer's rule to find the values of R1, R2, and R3. All right. Now for R1, R2, R3, first step is what? First step, you need to find the coefficient matrix. So let me write the coefficient matrix. Coefficient matrix, it will be what? 2, 1, 1. First will be 2, 1, 1. Then 1, 2, 1. 1, 2, 1. 1, 1, 2. Okay? 1, 1, 2. So what will be the determinant of it? We have already found the determinant of this, right? See, this determinant is 4. We have already found the determinant. So let me write it directly. That determinant, I'm sorry, just let me write it more cleanly. Okay. Determinant of A is equals to 4. Now here, why have I written it again here? Because I could have shown you just on the previous page that we have got the determinant. I have shown here for the reference because for A1, I will be changing the first column, this first column, with the B vector. Now what is the B vector here? That is our constants, right? The column vector of the constants. So what is it? It is ABC. So in this first column I will write ABC for A1. For second column I will write ABC for A2, and for third column I will write ABC for the A3. Okay, so let me find it. So let me write it directly. Let us use another pen. Okay, so here A1 is equals to what? A, B, C, and the second and third column will be similar. Okay, so 1, 2, 1, and then 1, 1, 2. And let us find the determinant of it now. How do you find it? A into 4 minus 1, 4 minus 1, minus 1 into 2b minus c, plus 1 into b minus 2c. Now, if you further calculate it, we get what? 3a minus 2b plus c plus b minus 2c. Now, what is this? 3a minus b and then minus c. So this is our A1. Okay, so let me find all the A1, A2, and A3. Then we will find the unknown variables. Okay, so let me find A2. For A2 we will use the B column, the second column, to be ABC. Okay, so what is the first column? It is 1, sorry, no, 2, 1, 1. 2, 1, 1. then A, B, and C, then 1, 1, 2. Then how will you find the determinant? Just like that, 2 into 2b minus c minus a into 2 minus 1 plus 1 into c minus b. Okay, so further calculated, it will be 4b minus 2c minus a plus c minus b. So this is basically what? 3b minus, oh, I'm sorry, I don't know. Is it fine? Just a moment. Okay, so where were I? Now coming to 3b, and then 2 minus 2c by plus c is minus c, and then minus a. Okay, so a2 we have got now. Now next is a3, and for a3 I have already told you we need to replace the third column with the b column. So what will it be? 2 1 1, then 1 2 1, then a, b, and c, which will be equals to, the determinant is equals to 2 into 2c minus b minus 1 into c minus b plus a into 1 minus 2 will be equals to 4c minus 2b minus c plus b, and minus a will be equals to minus a plus 3c minus b. So now we have got the values of a1, a2, and a3. Now what is the next step? Next step is to find the unknown variables. And what are the unknown variables here? That is r1, r2, and r3. Now how do we find r1? R1 we will find by determinant of a1 by determinant of a. So let me write that with a different color again. Let us take pink. That is our solution, right? So R1 is equals to determinant of A1 by determinant of A. Now what is the determinant of A1? What is the value? 3A minus B minus C, right? So it will be 3A minus B minus C divided by, what was the determinant A? It was 4. Yes. See, here it was 4. So determinant of A is equals to 4. So we will write divided by 4. And this is our answer for R1. Okay, now coming to R2. R2 is what? Determinant of A2 divided by determinant of A, and R3 will be what? Determinant of A3 divided by determinant of A. Now determinant of A is 4. Now we need to find what is A2. 3b minus c minus a. 3b minus c minus a by 4, and then determinant of a3 is what? 3c minus a minus b by 4. Okay, so these are our values of r1, r2, and r3. All right, so by the equations, by the Cramer's rule, we have got the values of r1, r2, and r3. Now we will say that here, hence we can say that xi belongs to r3. Okay, so let me write it in statement. We can say that when we get the solution, then we can say, so xi belongs to R3, which basically implies that R3 is a subset of L of S. And now what is L of S? It is linear span. Okay. Now coming to this, let us name it to be equation 1. Now again we will write again S is what? The set of vectors, right? So S is a subset of R3, and hence, therefore, we can write that L of S is a subset of R3. So if we name this to be equation 2, and we will write that what is the definition of it? What is L of S? And L of S is the smallest subspace is the smallest subspace of R3, which contains a set S, containing the set S. Therefore, by combining equation 1 and 2, we will get what? R3 is equals to L of S. So we will write with a different pen. Let us take this one. Combining equation 1 and 2, we get R3 is equals to L of S. Now we will show, therefore, this is proved that therefore S is a basis of R3, because we have proved that S is linearly independent, and we have proved that S generates V. All right, so we can say that S is a basis of R3. So first question down on our today's class. Now we will move on to our next question. Okay, so this is just for your practice. Okay, practice with me here. What was the question? Question is, show S is equals to 1, 2, and 3. Now here I won't write everything. I will just skip a little bit of parts so that it is faster. Okay, 1, 2, and 3, and 2, 3, 1, and then 3, 1, 2. I have written everything in the interactive slides. Okay, so from there you can get all the notes and all the steps, all the step by step. But here, as I'm teaching you now, I am not going over everything. I have already told you in the first question. Now I am just going a little faster so that you can practice more with me, right? So yes, now we have to show that S is a basis of R3. Now here we have already understood that what is the conditions for S to be a basis of R3. First condition is linear independence, and next condition is that S spans R3, right? So we will write that in the first statements, that S is linearly independent, and second is S generates V, right? And then next we will find the determinant. What is the determinant? A. Let us say A is equals to 1, 2, 3, and 2, 3, 1, and 3, 1, 2. Now, why am I finding the determinant? If the determinant is not 0, then we can say that it is linearly independent, right? And it is also helpful for us for the next part of the question, which is to show that S generates V using Cramer's rule. Okay, so what is the determinant? 1 into 6 minus 1 minus 2 into 4 minus 3 plus 3 into 2 minus 9. So basically 1 into 5 minus 2 into 1 plus 3 into minus 7. So it is equals to 5 minus 2 minus 21, which is equals to minus 18. Now minus 18 is definitely not equals to 0, right? So we will say that S is linearly independent. Therefore, we can say S is linearly independent. And here next step is what? Next step we need to write that let xi is equals to a comma b comma c, which belongs to R3, where for any vector where a, b, and c belongs to R. Okay, then we will say that now ABC is equals to R1 into the first vector, R2 into this vector, R3 into this vector, right? So what is the next step? Next step is that we will form the three linear equations. So what are the linear equations we will get from here? So let me write down that. Okay, so the linear equations which we will get from here is that for these are the coefficient matrix, right? This is the coefficient matrix. So let me write from there only. R1 plus 2R2 plus 3R3 is equals to A, and the second equation is 2R1 2R1 plus 3R2, then 1R3 is equals to B. And then the third equation is 3R1 plus R2 plus 2R3 is equals to C. All right. So from here, we have got already the determinant of A. Now we need to find the determinant of A1, A2, and A3. Now let us see how will we find it. Let us take red color. Okay. Okay, so A1 will be what? First, we need to replace the first column with the B column, right? What is the B column? That is the B column vector, which is the A, B, C. And what is the first vector? 1, 2, and 3. We will replace that with A, B, and C. So let us write A, B, C. And the second column is 2, 3, 1. 2, 3, 1. And then 3, 1, 2. 3, 1, 2. So let us solve the determinant now, which is A into 6 minus 1 minus 2 into 2b minus c plus 3 into b minus, sorry, Okay, 3 into b minus 3c. Okay, so is equals to 5a minus 4b plus 2c plus 3b minus 9c, which is equals to 5a minus b minus 7c. Okay, so this is what we get for a1. Now we will solve for a2 and next a3. Okay, so let us solve for a2. A2 will be what? The same A matrix with the second column replaced with the B column. So what is our first column? First column is 1, 2 and 3, right? So 1, 2 and 3. The next column will be A, B, C. Then it will be 3, 1, 2. And next we need to find the determinant of A2. So let us find the determinant, which is 1 into 2B minus C, 2b minus c minus a into 4 minus 3 plus 3 into 2c minus 6 3b, 2c minus 3b, which is equals to 2b minus c minus 4 minus 3a. So 4 minus 3 1, so 1 into a is a, so plus 6c minus 9b will be equals to minus 7b plus 5c minus a. So we have already got a1 and a2. Now the last step is the a3 one. Okay, so let us find a3. A3 is equals to, we need to replace the third column with the B column. So what is it? 1, 2 and 3, 2, 3 and 1, and then A, B and C. So here what is the determinant? It is 1 into 3C minus B minus 2 into 2C minus 3B plus A into 2 minus 9. 2 minus 9, which is equals to 3c minus b minus 4c plus 6b minus 7a, which is equals to minus c plus 5b minus 7a. Okay, so we have already got our three determinants, which is a1, a2 and a3. Next we need to find the unknown variables, right, which is the r1, r2 and r3. So let me find how to do it. Okay, so R1 is equals to determinant of A1 by determinant of A. So what is determinant of A1? It is 5A minus B minus 7C. 5A minus B minus plus 7C by, what is the determinant, which is minus 18, right? So let me write it. Sorry, it is minus 7C. And minus 18. So if I change the sign, because I want the denominator to be negative free, so it will be what? 7c plus b minus 5a by 18. Okay, so this is what we have for the r1 value. Okay, r1's value is this. Now we will find the value of r2. How to find that? R2 is equals to determinant of A2 by determinant of A. Now what is determinant of A2? It is minus 7b plus 5c minus A, which is minus 7b plus 5c minus a by minus 18. So change the signs, what we get? 7b minus 5c plus a, okay, by 18. So this is our second value of R2. Now next, what is the value? R3 will be what? Determinant of A3 by determinant of A. And what is determinant of A3? It is minus C plus 5B minus 7A. Minus C plus 5B minus 7A by minus 18, which is equals to, change the signs, C minus 5B plus 7A by 18. So again, we have got the values of R1, R2 and R3, and hence we can say that Xi belongs to R3, which implies that R3 is a subset of L of S. And next we will say that again S is a subset of R3, and therefore we can say that L of S is a subset of R3, and therefore from the two equations we get that R3 is equals to L of S, and hence we can say that S generates V. So the two conditions are proved that S is linearly independent, and second is that S generates V. All right. So I'm not writing all of the steps, right? So I mean, I have shown you the calculation, the writing part, the theory part, which you need to understand and write. So I'm sorry, you can do that on your own. Now, coming to our third question of the day, which is basically our last question. So, this is our last question. So, I think I should give it a little bit of honor, and I will show you a little bit of steps here. Okay. Though it is basically the same thing. Coming to the question. Question is to show S is equals to 1 1 1 first vector, 1 comma 1 comma 0 the second vector, then 1 comma 2 comma 0 the third vector is a basis of R3. Now here you need to write what? Solution for S to be a basis of R3, it must satisfy. First, S is linearly independent, and second is that S generates V. So for the first part, you need to do what? You need to take the determinant of A. Now, how will you do it? So A is equals to 1 1 1 first vector, 1 1 0 second vector, 1 2 0 third vector. Now you need to find the determinant of this, and you need to check that if it is non-zero, then we can say that it is linearly independent, right? So let us see what is it happening. 1 into 0 minus 1 into again 0 plus 1 into 2 minus 1, 2 minus 1, which is equals to 1, which is definitely not equals to 0, right? So therefore we can say that S is linearly independent. Therefore, S is linearly independent. Now, next we will write that let xi is equals to a comma b comma c everything. So let me write it. Let xi is equals to a comma b comma c, which belongs to R3, be any vector where a comma b comma c belongs to R. Okay, and next we will show that now a comma b comma c can be written as r1 into what is the vectors 1 1 1 plus r2, this is plus r2 1 comma 1 comma 0 plus r3 1 comma 1 comma 2 comma 0, 1 comma 2 comma 0. Okay, so from here we will get three system of linear equations, and then we will solve it using the Cramer's rule, right? So what are the equations that we get from here? It is 1 into R1 plus 1 into R2 plus 1 into R3, that is R1 plus R2 plus R3 is equals to A, and then 1 into R1 plus 1 into R2 plus 2 into R3, which is therefore R1 plus R2 plus 2R3 is equals to B, and the third equation will be 1 into R1 plus 0 into R2, which is 0, and again 0 into R3, which is again 0. So it will be R1 is equals to C. Now here, this in this question, it is fairly simple if you use the substitution method, because we are getting one of the value here itself right from the equations. But I would still suggest you please use Cramer's rule, because that will make you feel very comfortable with this rule. And even if you get typical sums, then you can solve it using that. Okay, so I will show you by Cramer's rule only. Okay. So what will be the, we have already got the determinant of A. Determinant of A is equals to 1. So we will directly jump to determinant of A1, right? So A1 will be equals to what? First column is A, comma A, B and C, because we need to replace the first column with the B column, right? And the second column is what? 1 comma 1 1 1 0, and then 1 2 0, right? And we need to find the determinant of it. How will we find it? It will be A into 0 minus 1 into minus 2, 1 into no minus 0 minus 2c, minus 2c, and plus 1 into minus c, right? Yes. Okay, so here how do you find it? Next step is 0 minus plus 2c and then minus c. which is basically C. So here we are getting that the x is R1's value is determinant of A1 by determinant of A. Now determinant of A is again 1. So we can say that whatever values we are getting for A1, A2 and A3, that is the value of the unknown variable, right? But you cannot write like that. You have to definitely write the perfect formula for the unknown variables, that is determinant of A1 by determinant of A. So anyway, we will come to that later. Let us first find the A2, A3. Okay, so what is the first vector? It will be 1 1 1, then A, B and C, because we need to replace the second column with the B vector, and then third is 1 2 0. Okay, and here if you find the determinant, you get what? 1 into minus 2C minus A into minus 2 plus 1 into minus C minus plus C minus B. Okay, so is equals to minus 2C plus 2A plus C minus B, which is equals to 2A minus C minus B. So this will be our value for R2. And for A3, what is the matrix? 1 1 1 1 1 2 and 1 1 0. Sorry, let me check once. Yes, 1 1 0. And then the third column will be replaced with the B column, right? So it will be A, B and C. And if you get the determinant, you get what? 1 into C minus 1 into C minus B plus A into minus 1. Okay, here there is no space. A into minus 1 is equals to what? C minus C plus B minus A. So basically answer is B minus A. So from here you need to write, you definitely know that these are the values of R1, R2 and R3, but still you need to show that what, how do you get it? Okay, so just write the formula. It will take 2 seconds hardly, right? Like for each. So R1 is equals to determinant of A1 by determinant of A, which is C. C by 1 is equals to C. And R2 is equals to determinant of A2 by determinant of A. And for determinant of A2, what we got? Just a minute. Yes, 2A minus C minus B, right? So 2A minus C minus B by 1. So it will be 2A minus C minus B. And R3 is equals to what? Determinant of A3 by determinant of A. So it will be B minus A by 1, which is equals to B minus A. So these are the values which we got for R1, R2 and R3. And next you want to write what? Then we can say that Xi belongs to R3. Okay, so I think I should not write that anymore. Like, okay, I'm just telling you, it will be what then. So we can say that so we can say that Xi belongs to R3, and which implies that R3 is a subset of L of S. Then again, you will say that S is a subset of R3, and then you can say that therefore L of S is a subset of R3. And from combining the both equations, you will get R3 is equals to L of S, and therefore you can say that S generates V, right? And from here you can say that S is the basis of R3 because it fulfills the two conditions. So that is basically all for today's class. Okay, just a moment. Okay, so we have done a lot today, I can see that. Okay, coming to our first portion from where we started. Okay, this is previous class, right? Okay, so we started from here. I can see that. Okay, so from Cramer's rule. Now let's bring it all together. Okay, now what is Cramer's rule? Cramer's rule is a determinant based formula for solving any n cross n linear system. Okay, as long as the coefficient determinant isn't zero. You replace the columns with your constant vector, compute the determinants, and then divide. That is all for Cramer's rule. And when it comes to proving a basis, it's literally just two steps. Check if determinant A is not equals to zero for linear independence, and then use the Cramer's rule on a general vector to show it spans the space. And then once you see that these two topics are really the same, on the same chain, on the same machinery, basis proofs become almost mechanical, and I love that. Okay, now if this video helped you, please give it a thumbs up. It genuinely helps the channel grow. And drop your questions in the comment below. I read every single one, and I'll see you in the next video. Take care and bye bye. If you have any problem in understanding how to solve the questions of basis vectors, answers, you can DM me on my Insta. And I would prefer that if you write the questions on the comments, okay, on the comment section. So bye bye, thank you so much for watching, take care, and keep doing mathematics.